All right, let's jump right in. A little while back, the internet basically exploded with these headlines that sounded like they were pulled straight out of a movie. Headlines that said Google scientists had actually created a wormhole. So, the big question is, did they?
I mean, let's be honest. When you hear the word wormhole, your brain goes to one place, right? Teleportation. The dream of stepping through a portal right here and showing up somewhere else instantly. And some of these reports were claiming that this wasn't just a theory anymore.
So this was the core claim that got everybody talking. That a team of physicists, using Google's super powerful Sycamore quantum computer, had not only built a tiny, working wormhole, but they had actually sent a particle through it. But here's the thing. That's not the whole story. Not even close. And frankly, it's not even the most interesting part of the story.
You see, to really get what this achievement means, we can't start in a modern lab with a fancy quantum computer. We have to go back, way back, to the 1930s, to a massive, bitter conflict between two of the greatest ideas in all of human history, and one very, very stubborn physicist at the center of it.
This is where our story really begins. It's a clash of titans, a battle of ideas between Albert Einstein and the new, bizarre world of quantum mechanics. And let me just say, Einstein, he was not a fan. So here was the fundamental problem. Einstein's entire world, his whole career, was built on general relativity. And a core, unbreakable rule of that world is that nothing, absolutely nothing, can travel faster than the speed of light. But then, this new kid on the block, quantum mechanics, shows up with this frankly weird idea called entanglement. It basically said you could link two tiny particles, and whatever happened to one would instantly affect the other, even if they were on opposite sides of the galaxy. And instantly, well, that means faster than light.
And Einstein hated this. He absolutely hated it. He famously called it spooky action at a distance. And you have to understand, for him, this wasn't just some academic disagreement. It felt like a personal attack on his life's work. In his mind, it meant one of two things. Either his theory was wrong, or quantum mechanics was just incomplete. So he decided to fight back.
And this is where it gets so fascinating. Einstein didn't just argue. He literally weaponized his own genius to try and prove that quantum mechanics was just, well, absurd. And in the process, he accidentally came up with two of the most famous concepts in all of physics.
Okay, so his first weapon was this brilliant thought experiment, the EPR paradox. He basically used the logic of entanglement against itself. He argued that if it were true, you could figure out both the exact position and the exact momentum of a particle at the same time. The problem? That would violate another key rule of quantum theory, the Heisenberg uncertainty principle. It was a genius move, trying to trap quantum mechanics in its own logic.
But he wasn't done. He wasn't satisfied with just one attack. He and his colleague, Nathan Rosen, went for what they thought would be the knockout punch, an idea that would explain a connection across space without breaking that cosmic speed limit. And what they came up with is what we now call an Einstein Rosen Bridge, or, as you probably know it, a wormhole. That's right. The wormhole wasn't invented for some cool space travel story. It was born out of an ego war, designed by Einstein as a weapon to destroy the theory he hated most. How wild is that?
Now, for the rest of Einstein's life, and for many, many years after, these two big ideas were treated as completely separate things. You had this paradox about quantum information over here, and this weird feature of space-time geometry over there. Nobody thought they had anything to do with each other.
Until, decades later, a new generation of physicists came along, and they looked back at Einstein's old attacks, and they saw something he never could have imagined: a connection, a bridge between his world and the quantum world he fought so hard against.
This revolutionary idea really took off with a physicist named Leonard Susskind. He looked at Einstein's two weapons, the paradox of entanglement and the bridge of the wormhole, and he asked this absolutely mind-bending question: what if? What if they're actually the same thing?
And this led to this incredible conjecture called ER equals EPR. The idea is that the spooky connection between two entangled particles is a microscopic wormhole. That instant communication, it's not breaking the speed of light. The information is just taking a shortcut to a tiny quantum tunnel that connects those 2 points in space.
And that is what brings us all the way back to right now. Back to Google's Sycamore quantum computer. Because if ER really does equal EPR, then it stands to reason. If you can control entanglement, you might just be able to simulate or even build a wormhole.
So let's simplify what the team, led by physicist Maria Spirapoulou, actually pulled off. Inside their quantum computer, they created these pairs of entangled qubits. You could think of these as the two mouths of the wormhole. Then they took a new qubit that was carrying a message and put it into one side. That message got totally scrambled, but then a perfect copy of the signal popped out on the other side while the original just vanished. The information had teleported in a way that perfectly matched what the theories say should happen if it passed through a wormhole. Okay, so this is the million-dollar question, isn't it? They made something that looks like a wormhole and acts like a wormhole, but is it a real tunnel through the fabric of space-time? Well, as with all the best stuff in physics, the answer is complicated, and that's what makes it so cool.
On the one hand, you've got the lead scientist, Maria Spirapoulou, and she calls it a baby wormhole. From her point of view, this is not just a simulation. It's a genuine physical manifestation of these properties. It's the first step, a proof of concept, showing that these wild theories can actually be built and tested in a lab.
But then, on the other hand, you have the skeptics, like quantum computing expert Scott Aaronson. He argues this is more like a very clever simulation. He says, think of it like folding a piece of paper so two dots on it can touch. You've created a shortcut for sure, but you haven't actually drilled a tunnel through the paper itself. It has the properties of a wormhole, but it's not a physical hole in space.
So with these two competing views, what are we supposed to think? Is it a historic breakthrough or just a neat computer trick? Well, the real importance of this whole thing lies somewhere in the middle.
So here's the real takeaway. No, they did not open a gateway to another galaxy. But what they did do is arguably way more important. For the first time ever, they created a system in a lab where we can actually test ideas about quantum gravity, the single theory that could finally unite Einstein's world of the very big with the strange rules of the quantum world. This is the holy grail of modern physics. It's the thing Einstein searched for his entire life. And in this just beautiful, poetic twist of fate, the key to unlocking it all might be the very concept he invented to attack quantum theory in the first place. His weapon became a bridge. And that's a story even better than teleportation.